Hi, I'm Mohammad Sharifur Rahman. I, with Dr. Pratheepan Yogarajah from Ulster University, have done this research. The topic of my research is evaluating the performance of common machine learning classifiers using various validation methods. The objective of this research is to find the best mix of machine learning classifiers with a different validation method to get the best result from the machine learning model. Uh, why we have done this? Actually, right now, many industries, including healthcare, banking, retail, manufacturing, transportation, and more, use machine learning models, and the machine learning models are employed in the healthcare industry to identify diseases and forecast patient outcomes. In finance, machine learning models look for frauds and assess the financial situation. So the outcome we get from machine learning has significant effect afterwards. So it's very important to get highest level of accuracy, precision, and recall rate of the output from the machine learning model. So we took this research, and what we have done actually, uh, we used 5 widely known machine learning classifiers, um, and they are K nearest neighbor, decision tree, naive Bayes, support vector machine, and random forest. And also we used KFold method, holdout method, and leave one out method as validator. We for this research we used the wine dataset of UCI machine learning repository. Uh, we used Python as our programming language, Weka as our tools, MS Excel, and Jupyter Notebook as our graphical user interface. We have measured the performance of our model through confusion matrix. The achievement from this research was actually we successfully could achieve 100% accuracy, precision, and recall. And also if one is scored in prediction, we have identified the following, like decision tree, naive Bayes, and random forest achieve 100% accuracy with the holdout validation technique. Random forest achieved 99.06% accuracy with the KFold cross validation technique. This is the highest from the KFold. And random forest achieved 98.12% accuracy with leave one out cross validation technique. So if we go inside, so something about our data set. Our data came from a chemical examination of 3 different Italian cultivars cultivated in the same region. The research detected 13 components in all 3 wines. And these 13 components are actually our 13 features. The data quality we got was good. There was no null value and there was no invalid value. There was 178 observations. The dataset had a class imbalance problem. Class 1 had 59 observations. Class 2 had 71 observations. Class 3 had 48 observations. Later, we balanced the class like this. If you see, we had a class imbalance problem, but after using smart function, we labeled all our classes and we worked with 71 observations for each class. And we followed all the processes of data processing steps, data processing steps were data collection, analysis, class balancing. Then we prepared our model. We didn't use feature selection because we know that these 13 components are the main components of the wine. So we didn't use the feature. So model performance judgment with various cross validation technique was done. Then we visualized the data and we came out with some observation. So this is the table of our experiment result, one of the experiment result. This is the result from classifier performance for holdout technique. We utilized holdout cross validation for all the classifiers models, splitting the data into 10, 90, or 20, 80, or 30, 70. In this way, 90, 10 ratio for training data versus test data. The table shows the below study. You can see that this is the 10%. 10% means here 10% data was used for the training and 90% data was left alone for the testing purpose. The result was not that good. You can see. Sorry. Then we tested with 20% data as our training data and 80% as test data. The result was not that good also. Then we used 30% as our training. In this way, when we went till 70% data as our training data and 30% as the test data, we found this is the place where our all the models, all the classifiers performed perfect. And after that, you can see that the performance is similar. So we can see that for the holdout technique, 70% for training and 30% for testing is the best combination. See here, random forest got 100% accuracy in 70% training data column, and from that it's all 100%. For Nave Bayes also 100% came when 70% data was used for the training purpose. And for others also, this is the column where they had the highest performance. Then later it either decreases or it kept same. This is the second experiment with KFold cross validation and leave one out cross validation technique. We used two-fold, 5-fold, 10-fold, 15-fold, 10, 20-fold, 50-fold, and 100-fold for all the classifiers, and 213-fold to simulate leave one out cross validation technique. So if you can see that in this case, two-fold cross validation technique didn't give that much good result, but when it goes till 10-fold, it gave the highest possible result. See, if you see the table, it will be more visible. Like in 10-fold column, you can see all the classifiers, almost all the classifiers got their highest result at that time. And after that, it either keeps the same success state or same correctness, or sometimes it decreases. So for the case of KFold validation technique, we have found that 10-fold validation sorry, 10-fold validation technique is the best KFold validation technique. After that, actually, it is not necessary. And 213 was our simulated leave one out cross validation technique. You can see that it's actually not necessary to go up to this level. So it's we can stop in 10-fold, and that's enough. So this is the result evolution. You can see all our 5 classifiers are here, and their performance with the best possible validation in all the validation techniques with the best possible combination. Like for holdout, we have kept 30% for the test. This was the best for the holdout, we know, and for KFold, 10-fold was the best, and leave one out is the separate one. So their performance in this validation technique are like this. So we can see that the best performer, the best classifier out of these 5 classifiers are random forest and Nave Bayes. Random forest is the overall winner because if you see the holdout, KFold, and leave one out average, it is 99.06. That's the highest one. So in our experiment, we found the random forest is the best one, the best classifier. And the holdout technique was the best validation technique. So this is the final graph. Actually, this will summarize the all. The accuracy score, precision, recall, F1 score are commonly used to assess the performance of machine learning classifiers. We all know the about the confusion matrix. It not only gives the accuracy rate or give a error rate, it gives why it is giving error. So this is the best way to judge a classifier. There are 3 different measures here: accuracy, precision, and recall. Accuracy means all true positive and true negative over all the observations. Precision means all true positive over all true positive and false positive. And recall means true positives over true positive and false negative. The kind of data set is actually essential in determining which metric is suited for evaluating a model performance. Normally, precision is the likelihood that an observation is positive when a classifier predicts it to be positive. Recall represents the likelihood that a positive observation will be recognized, and the mean of precision and recall is F1. So in this example, the wine dataset is a type of dataset that allows us to make decision without biasness. So F1 score is better for assessing model performance for this dataset. So if you see, the table displays the assessment score of the classifier model. Sorry. The random forest and the Nave Bayes classifier models are determined to have the best fit for this data set. Nave Bayes gave almost, actually it's 100%. In random forest, we got 100% F1 score. So our conclusion is when using the holdout validation technique, decision tree and random forest must use at least 30% of data as the training data set to achieve acceptable output accuracy. The best results were achieved when 70% data were used for the training. When using the KFold validation technique, more than 10 folds are unnecessary because performance improvement stops after this point. And we found that random forest and Nave Bayes outperformed the competition according to our analysis with the holdout cross-validation technique, where 70% of data was used for training. But sorry, there is scope for future work. We used a relatively small data set. In future, we can use a big data set with more observations and also with more classes to assess the same thing, if it performs similarly or not. So our recommendation is to use some different type of data sets in near future to test this similar test to check or validate our result. Thank you everybody for giving me time. So if you have any questions, please ask.